All right, so the basic form of scientific notation you probably know is it's in the form of some number with only one number to the left of the decimal point times 10 to some other number. So one thing to point out is that you always only have one digit to the left of the decimal. I don't remember why you have scientific notation. What's the purpose? You know, Danny?
It's when like a number's really, really long, so you make it shorter.
Basically, yeah. If you've got really gigantic numbers or really tiny numbers, it's a lot. It's easier to write in scientific notation than to write out the whole number. Now, this exponent here for the 10, it can either be positive or negative. If the exponent is positive, that means it's going to be a big number. And if the exponent is negative, that's going to be a small number. Okay, so here's my example. 85,700,000,000. So if I were to write this in scientific notation, right, we start, if you recall, by moving the decimal. If there's not a decimal already there, do you remember where it is? It's not written anywhere. It's at the very end, right? So the decimal starts here, and we want to move the decimal until there's only one number to the left of it. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Put it there, and then I'm left with 8.57. And I moved it 10 times, so I'm going to say 8.57 times 10 to the 10th. This is just an easier way to write that big number. And of course, you can also do this for, so this was maybe example number 1. You can also do this for really small numbers, right? So I'm going to go do 3 zeros. 0, 0, 0, 1, 5, 8, 3. Can everyone see this okay? Okay. So again, I want to move it so that there's only one number to the left of the decimal. So I got to move it 1, 2, 3, 4 times. And then you'll see I've got 1.583. And I moved it 4 times, so I can say 10 to the 4th, except this is a small number, so instead of being 10 to the 4, it should really be 10 to the negative 4. Okay, I'm going to ask you to do 2 of them the opposite way. I'm going to see what you can do. So I'm going to write them in scientific notation. You write them in regular notation. So you try this. 9.4 times 10 to the negative 6. And then you can also try 8.71 times 10 to the 4th. See if you can write those. So,
I have 4, 0. Oh, yeah.
yes, so the idea here, right, is if I do this, so I'm going to start by writing 9.4. And sometimes people tell you, like, whether it's negative, like go left or right, I always think that's confusing. I just think that, okay, if it's negative, that means it's a small number. So how do I make this small? By going this way 6 times. 1, 2, 3, 4, 5, 6. So there's my decimal, and every blank I fill in with a 0. So the overall answer to this one, I would say, is 0.1234594.
I also kind of think of it as like every time you move it one place, it's adding one to the exponent. So if you have -6, you're gonna have 5 zeros because for that one, yeah.
That's correct, and that works if you're going, if it's a negative exponent.
Yes.
It's going to be a little bit difficult. There's no similar rule for a positive exponent. Because if we think about this, right, 8.71 times 10 to the 4th. I've got to go 1, 2, 3, 4 this way. So this time it only ends up with 2 zeros. And I would like you to get in the habit of when you do these big numbers, don't just write it like that. Put the commas in there, right? Because we want to remember that this is a real number. So that's not too bad. That's fine. Now, the one that's going to be a little bit trickier is the metric prefixes and unit conversions. So